Well, thank you all for joining us. Welcome to Did You Know, the ESCO HVAC Show. Let me ask you a question. Have you spent very much time doing proper combustion analysis? And has anyone ever really explained the entire purpose of doing combustion analysis and utilizing combustion analysis as a portion of the entire efficiency of your structure, not just your piece of equipment? We're going to spend a little bit of time today talking about combustion analysis and why it is so important and how it can affect the efficiency of your system and the longevity of your system. So we want to welcome you today, and we want to welcome our guest. And Louise Kellar from UEI is going to be giving us a little bit more details into the maintenance side of it. And Jason and Eugene are going to help push the show along and give us a little bit better understanding of some of our differences between system efficiency and flue efficiencies. So if we think a little bit about combustion analysis, and we think about some of the resources that we have, I want to make sure that you know we can run over to UEI on YouTube. They got a lot of really good videos on their equipment and resources for their tools. Now, when we get into talking about the total system and understanding the resources that we have for better education, we're not going to spend a lot of time today talking about the actual sequence and the procedure of doing combustion analysis. We're going to dive deeper into the understanding of why we're doing it and how it affects our system and our equipment. Now, the ESCO group, one of our contributors, one of our sources of information is our Green Mechanical Council, where we dive deeper into that system performance. And we spend a lot of time talking about combustion analysis and how the performance of the entire system is a whole. It's not an individual component, it's a variety of different pieces. So we highly encourage you to take a look at that for some of the resources, and also take a look at Carbon Monoxide Safety Association, where we dive into deeper analysis of carbon monoxide and the process of combustion and utilizing combustion analyzers, and a lot of good instructional resources for that. So if we think about combustion analysis and we think about efficiencies of equipment, there are really two different aspects to take a look at. We can look at the efficiency of the equipment. We can look at the efficiency of the actual combustion process itself. So when we are talking about energy consumption, we have two primary sources of energy here in the United States that we're going to be focusing a lot on in this next year and over the next couple of years, probably the next couple of decades. Our energy consumption is going to hopefully decrease, but it's going to be because the cost of energy is going to increase. Now, when we look at our energy consumption, it's very understood the equipment that we are now working with. Most of it, I wouldn't say all, but a pretty significant part of our equipment is poorly maintained. In this particular analysis that was done, it's quite a few years older, but it was done on a large segment of HVAC equipment in the industry. It found that 68% of all air conditioning systems were improperly charged, causing excess runtime, causing excess energy consumption. We also look at about 70% of all those had improper airflow, which is anyone that's been a technician in the residential industry, you can validate that airflow is a number one reason for almost all of our problems, whether it's air conditioning or it is in the heating cycle. But one interesting one that caught my attention was 91% of systems remain untested for combustion safety and efficiency. So when we look at that, we have two different factors we have to take a look at: the safety of it and the efficiency of the actual combustion process. That is a lot of equipment that has never been validated for its combustion process. Now, if we had the opportunity to affect the fuel usage and the combustion of a cycle, wouldn't we take advantage of that and try to create a more efficient cycle for our customers, for our consumers, especially now that we're seeing increases in energy cost, drastic changes in energy cost? If we look at this report from the U.S. Bureau of Labor Statistics and we see the cost of imported natural gas to the United States, we see that there's about 165% increase for the year on fuel, natural gas fuel. We haven't seen that kind of a spike since we were back in 2003, when we really started looking at energy consumption in the United States. So now, not only are we looking at reducing our energy cost in the electrical consumption, we also have natural gas and propane fuels that we need to be more aware of. Because when we look at total cost, things that have increased in the last year, the main things that we look at are energy. all sources of energy. Yes, we're talking about decarbonization a lot more. We're talking about electrification a lot more. So we have to look at both sides of that industry and understand that there are things that can be done from both aspects. We're going to see a major change in our industry when we start talking about SEER2 equipment that will be coming out first of next year, where we're battling against those energy consumptions of our air conditioning equipment. Well, what about our gas heating? Well, yeah, we're going to have some different types of equipment as we progress. We've went from single stage to two stage to modulating. But what about the performance of that equipment? So let me ask a question of our audience. Why don't we perform combustion analysis? If anyone out there has some thoughts on that, hop into the chat and give us a quick shout out. See if we have some ideas. How about you guys? I know why. We won't spend a whole lot. Let's just think about that for a minute. Why are we not? Well, why do we test air conditioning systems when we're installing them? To set proper charge comes right out of the installation manuals, right? We're doing it because it's required in our installation. Well, when we start looking at gas furnace applications, it's actually not required in most installation manuals. That is the key. It's not been required, and many jurisdictions don't require that on initial startup of equipment. So why do we push that? Why should we? And are there other sectors of the industry that have chosen to adopt combustion analysis as part of their installation and commissioning? And yes, there absolutely is. So when we start looking at other sectors of the industry, other mechanical equipment, we can see in the boiler sections and we can see in hot water, we have manufacturers that are requiring combustion analysis on the equipment right out of the installation manual, but we're not in the residential furnaces. Eugene or Jason, have you got any thoughts on that?
I'll defer to Eugene. You have something there?
Well, actually, right on that point, actually, the question just popped in from an individual. I just want to tack on this, and I'll do that. So the question says, I work as a tech in an area where we have a lot of oil heat customers. And he's asking, how important is it to set up and test combustion efficiency? So I know we're talking about a lot of natural gas, but I think this is really, really
energy.
important.
It's a fuel.
The bottom line is, if we don't test, we don't know.
Well,
and especially with oil heat appliances, I mean, ideally, when we burn a hydrocarbon, we're producing heat, carbon dioxide, and water vapor. When we have incomplete combustion, especially, this is magnified on oil heat systems, in addition to the CO2 to heat to water vapor, we're also producing carbon monoxide, toxic substances, and also soot. We're getting a lot of soot forming on the heat exchangers. So when we're talking about efficiency, and this is from the National Oil Heat Research Alliance, and those folks said that even a 1/8 inch layer of soot forming on a heat exchanger is going to result in about an 8.5% increase in fuel consumption. So
crazy?
If we're using 8.5% more fuel, then our customers, the users of the appliances, are spending more money to get the same heating. So their efficiency is going is going way down. What I encourage techs to do is we really need to stress this to our customers. The homeowners should be stressing, how efficiently is my system working? So I always tell techs, when you go out to a job for an annual tune-up, to use a piece of combustion testing equipment to test the system once they get there, and then do their tune-up, do whatever they need, and then test the system again.
It's a validation.
Just to see the difference. Mrs. Smith, when I got here, your furnace was operating at 72.3% efficiency. And now after I did my annual tune-up, what some people call preventive maintenance, now you're running at 79.3 or 80.2. It's justification. And the more customers get comfortable asking to see what it is was done during the process, it's really going to help validate what it is we do in the field. because customers don't see a difference.
They don't know.
But
Right.
when they get their energy bill, when they get their oil bill, when they get their gas bill, they'll see it.
That's
But
right.
they can't see it right away.
No.
One of the myths I'd like to throw out there, one of the reasons when I ask people why they don't, the common myth is, well, there's nothing more on furnaces today. There's nothing to adjust. They took the air setters off. Everything came set from the factory.
I don't know how many times I've heard that from technicians.
That's untrue.
That's right.
They can't know what the fuel BTU content is in the area they're selling this furnace. They don't know what the fluctuations in the gas pressure are. There's a lot of things that today can be adjusted at how much air is in the room. Is there enough combustion air? Are we supplying enough dilution air? Are all the openings closed as they're supposed to? I mean, there's a lot of things, variables that still come into play. This is not just plug in and then walk away. You as Eugene said, you got to test it.
But you know what, Jason, let me ask you a question. When we talk about natural gas, we talk about fuel oil. Natural gas is a hydrocarbon mix.
Blend.
So natural gas is CH4, but it's also other hydrocarbons, just like fuel oil.
It has a range.
Oil. Yeah. So not all fuel oil is created the same. Not all natural gas is created the same.
Absolutely.
So I've heard people claim to be able to set up an oil burner, to set up a gas furnace by listening to the flame and looking at the flame. And you simply can't set up by looking and listening.
No, absolutely.
That's why Louise is in business.
Yeah, it comes into an analysis of the actual system to get a deeper understanding of the actual running of the piece of equipment. So we took a little bit of time. Louise and I got together and started discussing this topic of why don't people spend more time evaluating the efficiency of a structure? And are there any incentives? Are there any programs that are starting to do that? And we found that absolutely there is. We found that in the weatherization department, which a lot of people don't understand the weatherization side of the HVAC industry. Weatherization is a tool to understanding the entire envelope of your structure. And we'll dive a little bit deeper into envelope testing next week as we get a little closer into the understanding of this efficiency of our structure. So one of the things that we do know, the weatherization has a driving force to it for things to be tested and to be validated, unlike in our installation manuals of our gas-fired furnaces. So we do have steps that are being made that are looking at efficiency of equipment and the total structure, but it's not been done in our installation manuals, which is why it has not been required to this point. So after deeper conversations, we found that it is a really big push to look at weatherization and the combustion of our gas-fired appliances. So even if we look at like the Department of Energy is in a huge push right now for weatherization projects around the country to help reduce energy consumption. Just this year, we looked at a $40 million investment into 21 different organizations to dive into weatherizations for homes that need to be looked at. So Louise and I actually went over to one of our local representatives. We looked at the Indiana Community Action Association to see what they're doing to look at that actual testing of a piece of equipment that would be different than the installation manual for a furnace. And we were absolutely amazed at the depth of requirements for the commissioning of gas furnaces and just the inspection of the gas furnaces. In that, we'll find that there is a significant portion dedicated to just combustion analysis. So now we have commissioning documentation for pieces of equipment in the residential field, not yet required by codes and any building and mechanical codes, but it is starting to be more understood of the effect of the combustion analysis as it relates to our flue temperatures, to the efficiency of our combustion is going to end up correlating to the efficiency of our equipment. So a lot is starting to move in that direction. So it's important to understand how the combustion analysis process plays into the total efficiency of our structure, of our envelope, and why it's important to be able to not only purchase, but to maintain our combustion analyzers. So that's why we're here today, is to talk to Louise a little bit about combustion analysis from a manufacturer's perspective. So thank you, Louise, for joining us today.
Thank you for having me. I'm very excited to be here today. I know we've been talking about it for quite some time. As you guys see, by the way, on the screen, I do want to give a little plug that we do put out a monthly newsletter.
Yes.
Sometimes it includes tech tips. Sometimes it includes some new products that are coming out, and a variety of different other things. If you want to get registered to that, shoot me a quick email at louiseK@ueitest.com. Or if you have any questions after this presentation, feel free to give me an email and I'll be happy to get back to you with some of the answers.
That's awesome.
So I wanted to talk a little bit about combustion and the dangers of carbon monoxide today. But before I dive a little bit into that, I would like to do my due diligence and just talk a little bit about UEI test instruments on the whole. So UEI test instruments has been around since 1954. We are a second generation family owned business with operations around the world. I came from a background of retail, optical, and I found myself in UEI test instruments about 7 years ago.
Mhm.
And I'll be honest, I didn't know a thing about combustion analysis.
It's an
I
eye
didn't
opener.
quite understand why it was so important. I didn't
Sure.
know any of those things. And I've had a variety of resources that has allowed me to learn all of those dangerous things about carbon monoxide. And I've already started to create training programs just based on the experiences, based on working with contractors. And so, you know, one of the things that we'll dive into later in this presentation will be some of the products and where we came with for them. Up here, by the way, UEI Test Instruments does make a full line of heating and air conditioning products. We just were recently awarded the Dealer Design Award for our DL599, which is a really neat True RMS clamp meter. You can go to our website and read more about that product. But it is an exciting new product, and we're
Yeah,
always
pretty
looking
cool
at
piece.
to innovate things.
Sure.
So with that, I want to just kind of talk a little bit about carbon monoxide poisoning statistics. So when we really dive into that, you can find out that on average, about 50,000 people go to the emergency room a year for carbon monoxide poisoning. 430 of those people wind up passing away. And then we were talking about why don't people test and all of those types of things. We talked about the fact that there's no regulations, right? Like it's
Right.
not a
Sadly
required
enough.
thing to do. Which also goes into just having a home carbon monoxide detector. So only 27 states actually require a carbon monoxide detector be installed in new buildings, and
Right.
astoundingly enough, only 5 states require that carbon monoxide detectors be put in schools.
Isn't that a scary thought when you think about, now we're talking about safety. So not just the efficiency of a piece of equipment, but from the safety standard as well. That's a pretty staggering number to realize that we're not on board with the complete understanding of the gas-fired combustion cycle.
Yeah, and unfortunately, if you want to be really depressed for a day, if you just start searching carbon monoxide stories, there is one that comes out every day. There's some great
Yeah.
organizations out there that talk about the victims of carbon monoxide poisoning because it's carbon monoxide. It's just not something that leaves your system readily. So we want to make sure that, as contractors out there in the world, we'll talk about where some of those sources of CO are in the house. But we also want to talk about why it's so important to have your unit, your CO detectors regularly checked and tested to make sure that they're reading accurately for you.
So that brings up a good point, Luis. Part of what we're talking about is not only having your combustion analyzer for looking at the efficiency of your piece of equipment, we're looking at the total structure. So now we're looking at using a combustion analyzer and we're looking at things like carbon monoxide in the structure. So how much more sensitive would our combustion analyzer be versus, say, one of our standalone plug-in carbon monoxide detectors?
So I think that the difference is, and we can look at this on one of the next slides, is home CO detectors are a lot different, though, than what a carbon monoxide detector or a combustion analyzer is going to be when you're using it as far as walking into a customer's home.
Right.
Um, And so, and I have the statistics on that we'll get to in just a minute there.
Excellent.
There's some things though that you really got to remember about carbon monoxide. And the thing that I just cannot stress enough is that it is colorless, it is odorless, and it is tasteless. You know, if we've said it before in this presentation, even if you're not testing, you will not know.
Right.
And the dangers with carbon monoxide, right? So in small doses, it can create chronic illness. There was a story that came out of the Indianapolis a few years
Yeah,
ago.
right here locally.
It was, and it made national
Yep.
news. It was a story of a lady named Kathy, and she thought she had the flu for 10 years.
Isn't that crazy?
Thought she had the flu. I mean, and you read the story, and it's absolutely heartbreaking. And it turns out that she had just been suffering from carbon monoxide poisoning, and it was a low enough dose that it was just building up. So as she was unable to work, she was staying home more. Staying home more, her body wasn't able to purge that. And so that's the dangers. And, you know, I always want to say that I want to have a conversation with Kathy, and I want to ask her about her furnace in her house,
Yeah.
because that story was tied into a hot water heater.
Yeah, that's what I thought was a hot water heater scenario.
Yeah, and so it was. You can read the full story. We can add links at some point, but you know, my question that I like to ask contractors out there is, you know, if you have a properly tuned combustion analyzer and you've done all of that startup, when you walk into that house, I'm going to guess she probably had a gas furnace too. And so had one contractor have walked in with a properly tuned combustion analyzer into that house, they may have been able to detect that ambient air CO and saved her some of that time. So that's, you know, why having it properly maintained and just carrying one with you. You know, in worst case scenarios, you wind up with fatalities. You know, we talk, you know, I said that if you want to spend that day depressed reading them, there's a new story that comes out every day. Here in the Midwest, fall is under full swing, which means winter's right around the corner. And, you know, you get that bad ice storm. People start running their generators. You hear those stories. You heard them all about in Texas. Was it last year or the year before when they lost all of
When they
that
lost
power
power.
because of the ice storms,
Right.
and the power grids? So, you know, there's in the larger durations, you know, it can be very fatal for you. We look at one of the things that you look at if you talk to any of your first responders, 35 parts per million in the ambient air, which is, you know, it's not the fatal level, but they want to be called, they want to come in, they want to be checking in, or they're going to be shutting off those devices before they're going to call anybody because
Right.
they have the appropriate protective wear to be able to go in there. And you know what? I think, you know, obviously we want to make sure that our homeowners are safe. We want to make sure our business owners are safe. But quite frankly, I want to make sure that the contractors are safe. I've seen the places that you go into, and it's very important that your safety is a concern. You know, you don't want to walk in. We've heard the stories through the industry. Contractor went down. They were checking a furnace. It was down in the basement. They started not feeling well. They sit down. Do they manage to get back up? You know, that safety is a huge concern for us. If you don't test, you're not going to be sure. But the other thing
Louise,
is that,
I'm sorry.
yeah,
Yeah, I just wanted to tack on real quick. In your previous slide, you said 50,000 people a year go into the emergency room.
Right.
The problem is they don't say, oh, I have carbon monoxide poisoning. Let me go to the emergency room.
Exactly.
So they're going to the, and it's important that our viewers realize that they go to the hospital because they're nauseous, because they're throwing up, because they're dizzy.
Something's just
with
not right
allergies,
here with me.
and they don't know what it is.
Exactly.
So it's really, really important. And that was just to tie up, you know, to tie up everything you said in a neat little package, because yeah, 50,000 people are going to the emergency room, but if you fall and you break your foot, you know you broke your foot. I'm going
Right.
to the
It's
hospital
apparent.
saying
It's immediate response.
but yeah, we go to the hospital because of all the external things, because we don't feel good. So we delay going, like you said. because, oh, it's something I ate, it's something I did, it'll clear up. But like you said, it only gets worse. The more time you spend in your house and you're not going out, oh, I'm supposed to go out to dinner, I'm staying home, and you're making the situation worse. And you just summed it up. I just wanted to put a neat little bow on that.
Oh, yeah.
But
And
Yeah, no.
it's like you said, colorless, odorless, tasteless, but very deadly.
and an accumulating gas. It's not something that you absorb into your body and then it releases out as soon as you walk out into fresh air. Carbon monoxide is absorbed into the bloodstream.
Absolutely. And, it's an excellent point, though, that it's 50,000 known cases. We don't know how many other unknown cases there are.
Exactly.
So, and that, it goes back to making sure that, everybody out there, you have your home CO detectors. But for the contract level, making sure that you have your testing equipment regularly evaluated, making it sure it's recertified to ensure the reliability. Because there is nothing worse if you wound up with a dead CO sensor, you're not going to be able to detect. So that's the importance of having it maintained.
So, on average, what is the typical life expectancy of a brand new combustion analyzer, and how often should it be certified?
So you really should have it recertified every single year. And we'll
Mhm.
talk about some of those solutions just a little bit longer.
Mhm.
The average, length of how long a combustion analyzer lasts, it can vary. I in rough estimate, I would say probably about 10 years.
Mhm.
And we'll talk a little bit about that. But, just like cars, we can talk about cars like, some cars can go,
How well is it maintained?
300,000 miles.
Yeah.
And it's fine, regularly maintained,
Mhm.
and other cars they're going to only go 70,000 and the engine's
Right.
gone. So, and that also shows the difference in having something properly maintained to help expand that life expectancy.
Sure, absolutely.
Yeah.
So, what kind of numbers are we looking at? So, say we've got our combustion analyzer, so we're having it properly serviced. Now, we are doing our zeroing while we are outside.
Yeah.
We're not waiting until we're in the environment to turn the thing on to get it zeroed, because what if we've got 200 parts per million inside of our structure and we turn on our combustion analyzer, our carbon monoxide detector? What's it going to be reading?
Right.
It's going to
So,
be zeroing to the actual atmosphere.
yeah. And so, that goes back to that story I was talking about, Kathy, right? Like,
Mhm.
had somebody have had their combustion analyzer when they walked in that house, you know, they may have been able to detect that hey, maybe it was only 36 parts per million, but
Right.
that's still, in the danger level out there. Because, what we're looking at here are the CO limits, right? So this is ambient air CO. So
Right.
when you walk into a structure, OSHA has determined things like 50 parts per million for an 8-hour day. And so it's been determined, as you mentioned, it's an accumulating gas, right? So
Mhm.
you're exposed to it for 8 hours. You're not exposed to it for 16 hours. So how long can your body tolerate that? The other though thing that I want to point out when they're talking about CO and they do like the parts per million, what's okay,
What's
when
acceptable?
they generally do those studies and they come up with these, they're looking at the average adult male.
Right. Not a child.
And exactly. And so when you're looking at that, and that goes back to only 5 schools require
Mhm.
having a CO detector in there. And we know that schools are generally working on large boiler systems.
Sure.
So those are, primed to be having combustion analysis on them.
Right.
So 50 parts per million, 9 parts per million, by the way, is what ASHRAE says in a residential facility. You can see no more than that. And that, there's a variety of things, and we'll look at a couple of the things that cause carbon monoxide in the home.
Mhm.
Um, but, as we start going up, right, you have 200 parts per million, you're going to start feeling that headache, fatigue, dizziness. It's not uncommon, though, that you go in and you talk to a homeowner and they'll talk about having headaches.
Yep.
Um, and, they think that, maybe it's the job that's getting to them. But sometimes when we dig into it, we actually find out that they've been suffering from some of that carbon monoxide poisoning.
I found
Um,
350 in a residential structure one time.
I hope you got out of there quickly, and I'm
Yeah.
guessing you did because you're here to tell us
And
today.
and it was a call for sickness. So it was a residential complaint for, one of our routine customers that had an issue. They weren't sure exactly what it was, felt like their system was running differently. They weren't feeling well, went over and found 350 parts per million, found fluid obstructions. So yeah, that was a real life scenario.
Yeah. I tell you, I'm fortunate enough that I get to travel the country, and I get to hear different stories, right? So in my full length presentation, I have like about 5 stories I reference, and I would say probably about half of the combustion classes that I teach,
Hmm.
somebody comes back to me at the end of the class to tell me a story
Sure.
about something that just happened in their area. And those stories lead to more stories. And I think it's one of those things that everybody has a story. Everybody knows somebody, or they know somebody that knew somebody, and we just still haven't been able to get the grasp around why
Yeah.
it's so important to test.
Yeah, because
So
think back about that when you came to the industry, right? You didn't come to this industry as an experienced HVAC individual. You came as, a homeowner learning the trade. As a homeowner, do you ever remember a technician offering to do a combustion analysis of your HVAC system or giving you details on the combustion analysis of your HVAC system?
the answer to that is no.
Right,
And I actually, by the way, recently went back and I found some of the earlier, before I knew this industry, some of the technician notes.
right,
And there are literally things on the technician notes that say the flame looked right.
right. Nothing evaluated. And,
Nothing. It doesn't tell me what the guy. It doesn't tell me anything, right?
exactly.
And you were talking earlier about warranties.
Yep.
And we were talking about the startup sheets that we're seeing in the boiler world, that we're
Right.
seeing in the hot water heater world. And a lot of that ties in though because of manufacturer warranties.
Hmm.
You guys may remember the exact statistic, but I want to say it was north of 90% of equipment manufacturers, when they started evaluating things that went back, about 90% of it was from improper install, not
Right.
actual defective merchandise.
Sure.
um, so when you have a combustion analyzer and you're doing that analysis, you're using your manometer, you're checking the gas pressures, you're using all of the tools that you should have in your tool bag. You're really able to evaluate that system, and make sure that when you leave, it's set up right, because that also reduces your callback numbers.
Sure.
Because I know everybody loves callbacks, they make lots of money on them.
Right.
That's just not the case, right? It's extra time. They're losing out on going to another job. So why not make sure that everything's set up properly before you leave?
The interesting
Making,
thing oh, I'm sorry, go ahead, Eugene.
I was going to say, making money is a great thing. Making dead people is not.
Is not.
It's
No, absolutely.
sadly true. Yes.
Hmm. The thing that's always interested me in the industry, and remember, I came from the residential service sector before I got into commercial refrigeration. So I spent a lot of time in the residential industry. And one thing that always intrigued me with the HVAC industry is the way that we train technicians to tune equipment. So if we look at it from an educational aspect, and we have the opportunity to teach a practice that allows you to evaluate. Remember, a lot of these things that we're discussing is about how do you actually improve something? How do you measure something so that you have analytical data that shows a progression, that shows a increase, that shows a performance, that shows that you have actually changed and tuned something? And when we start talking about the efficiencies and the performance of a gas furnace, and we talk about that seasonal tune up, there's no way to validate that you've actually affected that piece of equipment besides maybe temperature rise, which you can do by changing a dirty filter, until we get into the actual analysis of the combustion to see the performance of the system at a beginning point and at an ending point. Eugene, you hit it so well on when we started this conversation about the only way that you can properly do an adjustment to a system is to have a foundational base, is to do that analysis before you get there. It only takes a couple of minutes. We'll actually show a video here in a little bit. We can do it in about a minute or two, and then have your foundational base for after you have tuned and made adjustments so that you have an outcome, so that you now have a validation of your process. So it's always bothered me, our furnace tune-up of technicians that have never been taught how to properly tune a gas appliance. All right, so let's talk about a little bit some common sources of our CO. So we know that we're looking at not only using our combustion analyzer for the performance of the system, for looking at the efficiency of our package, and now using it for evaluation of carbon monoxide. Give us some good examples of where are some of our sources of carbon monoxide.
Yeah, so one of the most common sources of carbon monoxide alarms going off in houses is actually cars. So we pull into the driveway, we have our car running. I think everybody's heard a story somewhere along the line that somebody knew somebody who pulled in a car into the house or into the garage. They answered a cell phone call. The carbon monoxide wound up going into the house and, either making somebody sick or killing the next door residents. I feel like there's been a variation of that story that's gone on because what a lot of people don't realize is that tailpipes of cars can start at 12,000 parts per million.
Right.
Which, if that previous couple of slides ago, at 12,800 parts per million, that is death within 1 to 3 minutes.
1 to 3 minutes.
So that's
a closed garage door with a vehicle running.
Exactly. And
or one of the scenarios that we've seen recently, what about a power outage and a Tesla with a gas-powered generator charging it inside of a garage?
I mean, there are a lot of variations that can come in that, right? And so that car running, because depending on how everything's built, they're very tight, and you can wind up with all that CO just pouring right back into the house. We were talking about those home CO detectors, though, and we were talking about where some of those limitations are, though.
Right.
And there's reasons that they have the settings that they do.
And I get that.
Again, they're very important to have in a residence. But the standard is that a CO alarm will not go off until it sees a sustained 70 parts per million for 1 to 2 hours.
And that's a brand new, out of the package, plug in the wall carbon monoxide detector from any supplier.
Yes. Yeah. And so, I always encourage people to know what the limitations are.
Sure.
70 parts per million, you're going to start feeling some of those effects after 1 to 2 hours. I don't have 70 directly in that one.
Sure.
But, you're going to start feeling a little bit ill with that. You are probably going to start seeing some of those signs of fatigue and headaches that are going to be happening there. They're important. There's reasons that they go off. Another reason that home carbon monoxide detectors go off are those backdrafting appliances. I talked about that story that happened outside of Indianapolis with Kathy. That was her hot water heater. So that was a possible option. We have dryers in our house. We have the ovens. All of those things can cause carbon monoxide to build up. But we need to make sure that we're doing our due diligence and checking out like the furnaces and those type of things. The other thing, though, about having just a combustion analyzer is the fact that it allows you to do documentation of what you started with. We were talking about that foundation, right? Like, where did we start with and where did we go? And we're full swing here in the Midwest in our clean and check season. So contractor comes out, they come out to my house. Everything looks good. They've ran their combustion analysis. Everything's fine. And we all know that we wind up with a few days that suddenly spike at like 90 degrees. And I'm not going to use my furnace for a few days or maybe a week or two. And what's happened in that meantime is that a bird or a squirrel has decided to take up residency in my chimney. And then what winds up happening, right? We're not getting that draft that we need. And that carbon monoxide is going to start coming in. So you could wind up in that situation like you did, Clifton, where you had to do a wellness check, right? Like somebody was feeling ill. I called the contractor back. We wind up, it's because a squirrel decided to build a nest in my chimney. So those can all cause carbon monoxide to flow right back into the house. The other thing, though, that I think is probably more on everybody's mind that's here at today's presentation is the next slide here, which talks about cracked heat exchangers. And I don't know if on your end, but it looks like Clifton may have frozen on my end.
Yep, it looks like Clifton froze a little bit. Well, while Clifton's unfreezing, Louise, I think it's really important that you mention that those parts per million levels are really based on average male.
Yeah.
So before we reach those levels, again, our children, ooh, our pets. So
Yes.
pets can get sick. Children
Yes.
can get sick. So it's important that we're really aware of that. So I wonder if we're still on. There he is.
Oh,
Clifton's back. Ah, there he is.
How about that? I think somebody
Yeah.
cut an internet
So
line.
yeah, there you go. So when children get sick or pets get sick, it may
yeah.
be before the adults in the family actually are exhibiting symptoms. We really need to be aware that if our child, if our young toddler is not feeling well, or the dog is getting sick, or the dog is experiencing some type of distress,
Right.
that's
Yeah.
a warning sign.
Absolutely.
Yeah.
Not 70
that's
parts per
an
million.
excellent point, because I'll tell you, I just got done. I was doing some training last week, and I got done at the end of the training, and a guy came back at the end of it, right? Because I said everybody has a carbon monoxide story, and it was actually a guy who, unfortunately, he lost his puppy.
Really?
The puppy was hanging out down in the basement, and
Mm-hmm.
there was an issue that was going on down there, and that was actually the first warning sign, was that the puppy passed away.
Oh, that's horrible.
Yeah. So, to me, I don't want to hear anything passing away because of carbon monoxide, especially
Something
when
preventable.
Right,
something
preventable.
is actually preventable.
Yep. One of the comments that was made was that this is not taught in their schools. And sadly, a lot of the times it's not dove into deep enough. I may get a overview, but because it's not required by manufacturers in the installation manuals, and it's not adapted into our building mechanical codes, it's not a procedure that is done regularly. Because when we talk about how regular should this be done, as a manufacturer of a meter, what is the recommendation for testing?
So, I mean, I think the annual, like, for your testing of your furnace, that's
Yeah.
every year you should have that tested. You
Yeah.
should have that clean and check. And then we'll talk about the clean and checks that we should do for our combustion analyzers.
Correct. Yeah, because the interesting thing about when we're looking at those references to doing combustion analysis and why it's not in many of the building codes, you'll find, though, there are a lot of references to doing regular maintenance and inspection on our equipment annually. And I think that's where this really falls into. So I hope down the road we pay more attention to the analysis of combustion and how it is affecting our equipment and how we can use it as a tool for our entire envelope.
Yeah,
Unfortunately, I'm sorry. Unfortunately, Clifton, right now, a lot of things that are being taught are the old school rules of thumb.
That's right.
Watch the flame. Does it
Adjust
waver
the shutter
when the
until
blower
it gets a
turns
tip.
on? Yes, there's again without an analyzer, you're guessing, and it's your
Absolutely.
best guess, and you have to be willing to bet that your guess was correct. That I looked at that flame, I didn't see any movement. In a lot of these furnaces, you have to have the door off in order to see all of the flames. So you're operating it under
an unnatural
abnormal conditions, right? So again, these rules of thumb have to be replaced with concrete, solid data, as you mentioned earlier.
And that's really what we're here to do. Is we're here to show that there are principles and practices that have changed over time. Equipment has changed over time, and unfortunately, some of that stigma has came to the point of, well, it's a new piece of equipment. There's not a lot that I can do to adjust this. Therefore, I'm going to fire it up and I'm going to check the temperature rise, and if we're good, we're good.
Yeah, the manufacturer adjusted it before I got it.
Correct. And that is not the proper procedure. So we're just trying to help enlighten the fact of why we try to promote this, because teaching combustion analysis is not something new. We've taught combustion analysis for a very long time. What we've not done is explained all of the importance of combustion analysis and try to move past that stigma of, oh, it's another step that I should do. Well, it actually kind of fills right back into that same statement. There's not very many things for me to do. Well, instead of adjusting shutters on ribbon style burners like we used to do, now you've got just enough time to go do a combustion analysis. And so you're not putting more time into it. You're using the same amount of time that we would have serviced an older piece of equipment. And now we're doing a complete validation of this newer piece of equipment. So we're only talking about a few minutes to do a complete evaluation of the system.
Absolutely. And I think it's just it's an important practice.
It is.
Just to get into the habit of doing that. And combustion analyzers, by the way, can provide you much more information than just what the efficiency levels are
That's
of
right.
that equipment. It'll tell you more than just what the CO levels are that are going out the flue. That combustion analyzer can even help you diagnose or get you on the right path to even finding out if maybe you have a cracked heat exchanger.
Mhm.
So there are ways to perform a cracked heat exchanger integrity test. And that's going to be looking at the differences before and after the blower kicks on of your O2, your CO, and your excess air. So it's something you can do really with any combustion analyzer. I will say that, it is a feature that we put into all of the UEI combustion analyzers now in our core series. And it does the math for you. So you can actually get that snapshot all on a printout to help you diagnose and determine if, hey, further investigation is necessary.
Exactly.
So, a heat exchanger test, it's a good idea to do one of those because you just never know. Visual inspections are hugely important. But if you can have some more documentation, it also
Right.
helps support that.
Something to, something validating that you can give to that homeowner.
Yeah, and there's, a lot of things about having that validation, right?
Mhm.
In the society that we live in, we're doing this online. This is going to live in perpetuity for whatever we decide that we've said today.
Right.
And the thing about that is sometimes people put out really great, accurate information out there.
Mhm.
And sometimes there's not really great, accurate information out there. And YouTube, quite frankly, doesn't always know when or how good that information is.
That's
So,
exactly
how
right.
many times, how many of our contractors have told us, well, the homeowner watched a YouTube video, or you show up and they've done something like that. And having an analyzer and having those tools to actually show, because your average homeowner doesn't have a combustion analyzer. They don't understand what combustion analyzation is. Hopefully, they're not tinkering with a gas valve, but you don't know. But they've all watched that YouTube video that says, oh, this looks really easy. I'm going to do it.
Exactly. Great point. I'm so glad you bring that up. It's the
I
whole
do.
reason we're here.
It
It's
is.
it's getting quality information from trusted sources. And I don't know about you, but I think I would listen to the author of the book and the manufacturer of the equipment giving me recommendations on how to properly do something. So
Yes.
I'm so grateful for you all being here today. Very, very, very good topic. So let's
Yes.
talk a little bit about that combustion analyzer. So we know that it's a multi-purpose tool. It's not just used for one function. It's not the tool that you use to go see once you think you may have a bad heat exchanger. It's not that, oh, I might have a bad furnace, so I better do a combustion analysis on to verify it. It's the tool that you use before you even get to that step. It's not the last step, it's the first step in the entire process. And we know that they could have potentially a 10-year life expectancy. We know that they need maintenance, like every functional piece of equipment. Probably is going to need to be serviced annually or so. So let's talk about that a little bit. Let's
Yeah.
talk about the services that are available for UEI combustion analyzers.
Yeah. And so I wanna start with this before we flip to the next. Um, a combustion analyzer. You get your service like contractors are making money. Our clean and checks are the important things
Mhm.
because the homeowner wants to ensure that their furnace is working properly for the coming season.
Right.
Combustion analyzers are no different. It's no different than getting the oil change on your car, right? There are
Sure.
things that you do
It's a routine
to make
maintenance.
sure that it's always running at its optimal peak performance.
Yep.
And one of the barriers, though, that we heard from contractors about having combustion analyzers and doing combustion analysis is there's two costs to it. So there's your initial investment of buying a combustion analyzer. You know
Hmm.
you need one.
Right.
But the second is what does it cost? How often do I have to do it? And why should I do it? Like, what are the benefits? What are the things? And we spent a lot of time looking at that and trying to break down those barriers because we know how important it is to have a properly tuned combustion analyzer. So we tried to remove all of those barriers for everyone out there. So we debuted a new series of combustion analyzers. They all came with the initial 1-year warranty. And then we said, you know what? We want to make sure that everything's included in that. So send it in the next year, which you should have it annually recertified. We're going to extend that warranty for you for up to 10 years.
Okay. So as long as you're maintaining, doing the
As long
proper
as you're
routine
maintaining it,
maintenance.
right? We're going to give you another year of warranty.
Sure.
Then the next thing that we did is that we heard that it takes a long time for it to get back. So, you may be out of your analyzer for quite some time. We redesigned some operations in our Indianapolis facility, and we'll even take a little bit of a look at that in a minute.
Yeah.
Things that are coming into Indianapolis on a Tuesday morning are actually going out on a Tuesday afternoon. So we took out that, it's in the middle of the season, like I don't want to have it certified.
Right. I can't be without this for
I can't be out
2
without
weeks.
it. Sure. And then the other thing is that there was an issue. Okay, so now I have this analyzer and I'm going to send it in and I'm paying to send it in. And now I have to ship it. And how do I ship it? What do I use? What's the best way? How much is it going to cost? So we actually came out with a program that's going to give you a free UPS label. Nice. So that label is actually, you go on our website, you fill out your information, you go to a little bit of another little box there. It asks for like 2 pieces of information. Boom. Now you have a UPS label. Nice. So we have really tried to take all of that out of there. And because of the way that we were able to redesign operations, the way that we do our sensor configuration versus some of the other combustion analyzers out there, we're able to even give you reduced pricing on it. So, just like when you look at the model of a car, right? You're going to go buy a car and you're like, oh man, I really like this car, but I know if something ever goes awry.
What's my warranty and my cost of maintenance?
Exactly. So we're also going to give you a great price on that unit, on that service cost, because we want to make sure that there are no barriers for you when doing combustion maintenance. That's how much we care about it and how much we think that every contractor out there should be doing combustion maintenance.
Yeah.
In the United States, it's not mandated.
No.
If you look at our friends overseas, though,
they take it very seriously.
A lot of regulations. Even our friends to the north have a lot more regulations on those because there is that push. We're seeing a lot going on in the EU right now, right? Because of energy efficiency.
Energy cost.
That's the things that they're talking about. And they're looking at how much can the grid hold? Is this, are these units working as effectively as they should be?
Right.
So it's the same thing though, right? Like you tune and check a furnace 1 year and you still need to go tune and check the furnace the next year.
Right.
So with the analyzers, it's the same thing. You should have those professionally recertified. And a recertification, by the way, just so everybody's clear on that, it's more than just, checking the calibration. It's going to check those temperatures. It's going to check if it has pressure in it. It's a whole comprehensive thing for everything because we just don't want the barriers. We want to make sure that you're getting accurate and reliable results. Because before you get into that, one of the things I was going to say about the manuals, though, they don't regulate that you have to do the combustion analysis necessarily. But have you ever read how many warnings of carbon monoxide are in an install manual?
Yeah, pretty significant.
Like multiple times a page.
Right.
It says something like improper installation may result in. And you see that 2-3 times on a page, those big warning signs. And so again, without having properly tuned equipment, how do you know that furnace is properly tuned?
What's the validation for that?
There are stickers all over the unit as well, warning stickers and caution.
Sure.
So it's not just in the manual. They put it everywhere.
Everywhere you can look, there is a yellow warning sign. And maybe that's part of it, is that people have just become immune to seeing that yellow warning sign.
I think so.
They're there for a reason.
I think so. And so many people refer to their installation manual for a piece of equipment and, look at that as the sole component for doing an installation and not look at the bigger picture of all of the additional things that goes into that. You don't read the installation manual to know how to do all of your sheet metal work. You don't read the installation manual to know your complete installation. There are components to that that need to be done through proper education. And there are tools out there. We've had combustion analysis programs for decades with complete program details, and it just hasn't been adopted the way that we would hope that it would. So I really hope that this, sheds a little bit of light on that scenario. Now, one thing I wanted to definitely do is I had the opportunity to run by UEI with Louise and go through what the facility looks like and what that turnaround looks like, because I was very impressed by that expedited delivery. So I wanted to see what things were. So let's take a quick look at UEI.
So from our unassuming building, when you come in, we did a thorough video with us a couple weeks ago. But you walk in, we have our facilities set up. I do want to point out, we said we're a family-owned business. In every one of our offices, you will find a picture of our founders, Douglas and Betty Kane, in their honor. We have a pretty good sized warehouse to get all of that product out to you quickly with the UPS.
And I should say tons of UPS packages coming in daily.
And that was a slow day, by the way. Like that day that you were there was not in the fastest or the largest deliveries that we'll get. But we redesigned everything to make it as efficient for it. Everybody in our facility has really adapted to be able to make that turnaround time.
That quick turnaround time.
I was
it was a busy place.
It was nonstop. I think Clifton might have gotten a wave, and everybody was just off and running to be able to
do their
get
part.
all of that. Yeah. But they have a great system that they were able to put in place. Last year we were running about a 1-day turnaround time.
Okay.
And they looked into it of what can we do better, and we're always looking to do better. So
sure.
And then we actually got to go visit our friends at Inca, where they were kind enough to let us record in their tiny house and do some combustion analysis.
And part of that was to show, an improper reading on an analyzer, how much it can throw off your readings. So this is the same piece of equipment. These are two different readings that you're going to see based on the airflow through the sensor. One reading showing that we had about a 81.1% efficiency. And here in a minute, you'll see another one that's down around 78 or so. So just showing that if our sensors are not reading properly, we could still get a reading. It just may not be calibrated correctly. Yeah, there's one showing about 78. So it really comes down to understanding that they do take maintenance, and they could be off and not completely bad. And we also did a little bit of validation on a unit with a failed heat exchanger.
We did. You don't find a whole lot of those units anymore, though, so I'm real excited that one still exists to be able to do some testing on it.
With.
Yeah. But so that was part of that heat exchanger integrity test that I was showing.
Exactly.
So you'll be able to see your before and after results. Yeah.
Fantastic.
That was
Good
cool.
stuff, everybody. Yeah, it's a lot of fun. Got to get a different perspective. Like I said, when I grew up in the industry, combustion analysis was something that you did when you thought that you had a bad heat exchanger. Right? It wasn't a first resort, it was a last resort. And so the whole goal is to help people understand that with proper training and proper educational programs, you can get a bigger picture of the analysis of not just the piece of equipment, the combustion process, and how our entire envelope is being affected by that piece of equipment. So it really is a multi-purpose tool. We're looking at it for efficiency and combustion. We're looking at it for the health of the environment. A lot of people don't look at a combustion analyzer as a carbon monoxide detector, but why not? That's what we're doing with it. So we're just measuring gases. So it's very important that we utilize that combustion analyzer in multiple functions and that we educate on how to do that properly. Jason, Eugene, got anything you want to ask or dive into any deeper? Let me take a look at the chat. I've got quite a few people out there, but I don't know that there's a whole lot going on, just that's not taught in most schools, and which is so true.
I think that's one of the conversations that we've had. And I've had those conversations with a lot of instructors, and there's there's kind of two components to it of why I hear that it's not being taught.
Sure.
One, they were never taught, so they don't feel comfortable teaching it.
Exactly.
And that's probably the biggest thing is I don't feel comfortable because I don't feel that I understand it well enough to be able to teach it. And I think it's,
Louise,
trying to break down those barriers, and you guys are great at that.
Louise, that is so important because, we deal with so many schools across the country. And my mantra has been, if a teacher doesn't know it, they can't teach it. If they don't teach it, the students don't learn it. And if the students don't learn it, they can't do it. So,
Yep.
we really appreciate you taking the time just to bring this to the forefront. It is really important. Meaning you stressed carbon monoxide, colorless, odorless, tasteless,
Mhm.
and it's really, really important that, that we help the industry realize the importance of testing.
Yeah. Absolutely. And, I'm so grateful that I was able to be on the show today, to be able to work with all of you guys, because you put on a great presentation, and to keep stressing this. So, future generations, the technology of the furnaces that we were talking about, they're not the same technology that grandpa worked on or dad worked on.
No.
And so having those tools that are going to help you work more efficiently to be able to diagnose are just, they're so much more crucial right now, than, if you think about the old wet kits, that was a whole, that was the start of the combustion, but, it's come a long way. And that equipment that they were testing those wet kits with are vastly discontinued. So
Technology of 20 years ago is different than the technology of 10 years ago versus the technology of today. So we're in a very different environment than
yeah.
most of us as technicians when we grew up in. We just didn't have the equipment, let alone the education to go along with it.
Yeah. So yeah, I don't understand it. I'm not going to teach it. That's the first component that I normally hear.
Yeah.
And then the next thing I have is their students. Combustion analyzers are too expensive.
Sure.
And then I have to go do all of this maintenance. So again, why we're trying to break down those barriers and just make it so much more accessible to everybody to be able to do that testing. Exactly.
All right, fantastic. I don't see any other messages coming in, so it must mean we've had a good presentation, and we really look forward to future conversations with energy conservation and with looking at our entire envelope and looking at all of our components as being part of our energy efficient structures and what we can do to better educate, to better learn, and to better preserve the environment that we live in. Thank you, everyone. We'll see you next week on Did You Know? The ESCO HVAC Show.
Thanks, everyone.